Lesson 5, two graphing stories. In this lesson, we're going to graph piecewise functions from a real-life situation or a elevation versus time graph from a real-life situation. And we're going to actually find the point of intersection because we're actually doing two different graphs on the same coordinate plane. Okay, this is just going to give us, this first example is going to give us an idea of what we're going to be doing, but we're not actually solving for anything. So let's look at the story about Maya and Earl. Maya and Earl live on opposite ends of the hallway in their apartment building. Their doors are 50 feet apart. Each starts at his or her own door and walks at a steady pace toward each other, and then they stop and they meet. Okay, two pieces of information that is missing that is very important to this story is how fast they are walking. So I've added this information off to the side right here. So Maya, this is the first piece of information that you need. Maya is walking at a constant rate of 5 feet per second. And then the second piece is Earl is walking at a constant rate of 5 feet per second. Whenever we tell you that it's a constant rate, what we're actually telling you is a slope. So Maya's slope is 5 feet per second, or 5/1. And Earl, on the other hand, his slope is 2.5 feet per second, or 2.5/1. Okay, now what they tell us in the story is that they are on opposite ends of the hallway and their doors are 50 feet apart. They didn't tell us which end of the hallway that they're on, so I'm going to start with Maya at the top of the graph and Earl at the bottom of the graph. You could do this vice versa, it wouldn't really matter. Notice our graph is missing some numbers, so that's the next thing we're going to have to do is we're going to have to label our graph. And I'm going to count by 5s. So I've got 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. So that's the distance that they are apart. Time is always on the x-axis, and distance or elevation is always on the y-axis. Okay, so this is distance. Remember, these are distance versus time graphs. And so this is going to be the time over here. And they didn't actually give us a specific amount of time, but this is distance in feet. And they said that the doorways were 50 feet apart. So Maya's doorway, I said I was going to put that at the top. So this dot right here is going to represent Maya. And this dot down here is going to represent Earl. Remember, labeling is very important. Okay, and again, this first example is just to give us a general idea of what we're going to be doing today. Okay, Maya has a slope of 5/1. So that means that we're going to go down 5 and over 1. Since my y-axis is actually in increments of 5, that means I'm really only going to go down 1 space because each space counts as 5. So from 50 down to 45, that would be 5. And then over 1, that would be a point. And I'm going to keep going down 5/1, down 5/1, until I go across the graph, down 5/1. Okay, my times, I can just call these, I don't know if they're minutes or seconds, they didn't give us a specified amount of time or a time that it started, like at 8 o'clock or anything. So but they're meeting and they're in an apartment. Was it an apartment? A hallway. So these probably are just like minutes. Okay, so that's going to be Maya's line. Just going to draw a line in there. And next, I'm going to have Earl. I'll actually make Earl's dot blue so we can tell. Now, Earl's slope is 2.5. He's a little slower walker than Maya is. And 2.5 with respect to 5, that's halfway up. That's half of 5. So I'm going to go up 2.5 and over 1. So 2.5 is halfway up and then over 1. So that point is up 2.5 over 1. The next 2.5 up will take you to 5 and over to 1. Up 2.5 over 1. Up 2.5 over 1. And keep repeating that. I go all the way across the graph. That'll actually tell me how long it would take him to get to Maya's door. So there, that lines up with the 50. That would tell me how long it would actually take him 20 minutes to get to Maya's door. But what we're actually looking for is where do they meet. So we're looking for this point of intersection here, which is this point right here in the middle, which looks like it's at approximately 6.5 and at halfway between 15 and 20 feet, which up halfway is adding 2.5 feet onto 15. So that's kind of the general idea of what we're going to be doing today. There's a little bit more to it, but that's the idea of the types of graphs that we're going to be making today, are distance and time graphs. Okay, so let's go on to a more specific story that actually gives us all of the necessary information. Okay, this is actually over on the next page. It's example 2. It's about Duke. It says Duke starts at the base of a ramp, so we know we're going to be putting Duke down at the bottom of the graph this time. Duke starts at the base of the ramp. He walks up it at a constant rate. Okay, so it's a constant rate right there. So that's where we're going to find out about his slope. His elevation increases by 3 feet every second, so that would be Duke's slope. Just as Duke starts walking up the ramp, Shirley starts at the top of the same ramp, 25-foot ramp, and begins walking down the ramp at a constant rate. So she's going at a constant rate also. And her elevation decreases by 2 feet every second. Okay, so question 5 says sketch the 2 graphs on the same elevation versus time axis to represent Duke and Shirley's motion. So first of all, let's look at Duke's slope. They said that Duke, his elevation is increasing by 3 feet every second. So that would be 3 over 1. And that was 3 feet for every 1 second. So that would be his slope. And then further, he tells us Shirley. So Shirley starts at the top of the ramp, the same 25-foot ramp. So that's the starting point is going to be for Shirley. And she's decreasing her elevation 2 feet every second. Oops, it's not Shirley with an E. So Shirley's slope is negative 2 feet for 1 second. She's negative because she's going down the ramp. One of them is always going to be negative, whatever one is up at the top and going down. whatever one has a decrease in the slope. Okay, so Shirley's starting up at the top of the ramp at 25, so this is Shirley. And Duke is starting down here at the bottom. So that's Duke. So we're going to count out our slopes. Duke goes up 3 over 1. So I'm going to count out my slope here. Up 3 over 1. Up 3 over 1. And I'm going to count that to the end of the graph. Technically, the next point would be off the graph. Let's make a line, connect our points. If you don't count it correctly, you won't be able to connect your points. So something will go wrong. And then Shirley is going down 2 feet over 1. Let's make Shirley's line. And that line's not perfect here. Not going to actually 2 points. There we go. Okay, so here's the point where they meet. Okay, we're going to do a couple things with this. We got some questions now. Questions so I can actually see them. The graph. Okay, so the first question says, what are the coordinates of the point of intersection of the 2 graphs? And then that point is actually going to tell us some information. So first of all, the point of intersection here is, you always do x first, over 5 and up 15. 5, 15. That's the point of intersection. So the coordinates are 5 and 15. And then what time do they pass, or what time do they pass each other? It would be the 5. That's the x coordinate. So they pass each other at 5 seconds. And then it doesn't ask us this, but 15 would actually be at what distance? So they're passing each other at 15 feet. So 5 seconds, 15 feet is when they're passing each other. That's what the 2 numbers represent. Okay, we're going to go one step further now with this, and it says write down the equation of the line that represents Duke's motion as he moves up the ramp. And then we're going to write the equation of the line that Shirley's motion is, and then we're going to actually show that that point works. Okay, so starting off first with Duke. And his equation. So his equation would be y equals, we're writing our equations. The equations are always the y equals mx plus b. So his slope, we said, was 3, if I remember correctly. Yes, so Duke's slope was 3. 3 over 1 is the same as the same 3. So y equals 3x. And then his starting point is actually down here at the bottom at 0. So it would be 3x plus 0. So we don't really need the plus 0. So that's Duke's equation. And then Shirley's equation. Is this one Duke and Shirley? Yeah. Shirley's equation is y equals negative 2x. But she started at the top of the ramp, which was 25 feet up, so it'd be negative 2x plus 25. And now I just want to verify that that point, 5 and 15, actually works for both equations. So the way that I would do that is I would actually plug in the 5 and 15 into the equations. So for Duke's equation, I would take 3 times 5. And does that actually come out to 15? So this is verifying. And yes, 3 times 15 is actually equal to 15, so that works for Duke's equation. And then let's verify for Shirley's equation. Is negative 2 times 5 for x plus 25 equal to 15? Well, that would be negative 10 plus 25. And negative 10 plus 25 is in fact 15. So that works for Shirley's equation also. Okay, so that's verifying that that point works for both equations. And that's exactly what happens when you have a point of intersection. If you found the correct point, it should actually work for both equations. Okay, let's look at one more. This is about Jeremiah and Andrew. Jeremiah and Andrew live on opposite ends of the hallway in their apartment building. Their doors are 36 feet apart. Okay, so the doors are 36 feet apart. It's an important piece of information here. Each starts at their own doorway and walks a steady pace toward each other, and they meet. Jeremiah walks at a rate of 5 feet per second, so that would be Jeremiah's slope. And Andrew walks at a rate of 4 feet per second, so that would be his slope. Okay, so we've got Jeremiah's slope and Andrew's slope. So we're going to sketch the situation here. So let's start off first of all with Jeremiah. And his slope. And they said that Jeremiah walked 5 feet per second. And then Andrew, his slope, and he walked 4 feet per second. Okay, and the other piece of information that we were given is that the doors are 36 feet apart. So that means one has to start at 36 and the other one has to start at 4 feet apart. 4 feet. So I'm going to put Jeremiah at the bottom of the graph. It really doesn't matter. I'll put Jeremiah down here. And Andrew up at the 36. Whoever starts up at the top of the graph has the negative slope. Okay, so since I put Andrew at the top, he's actually going to have a negative slope. He's going down the graph. Okay, so Jeremiah, starting with him. Now, another thing we need to notice is that this graph, the y-axis, actually both of them, they're counting by 2s. So for Jeremiah, I'm going to go up 5 over 1. We're counting by 2s. So up 5 puts me halfway between 4 and 6, and then over 1 is going to put me right in the middle of the graph. That's up 5 over 1. And then up 5 more would take me to 10, and over 1 would take me to 2. Okay, from 10 up 5 would take me to 15, and over 1 is going to take me to 3, so that's halfway between 2 and 4. And we'll keep it going like that. Up 5 from 15 will take me to 20, and then over 1 more will take me to 4. Up 5 from 20 will take me to 25, and then over 1 more will take me to 5, so that's going to be the middle. What you'll notice happening here is that every other point is kind of in the middle of the squares. So up 5 more from 25 will take me to 30, and over 1 more will take me to 6. Up 5 from 30 takes me to 35, and over 1 more takes me to 7. So that's Jeremiah's graph. It's really tricky when the scale is not ones. So be really careful on those. Makes them hard to count. Okay, there's Jeremiah's graph. Now Andrew is going down 4 over 1. So from 36 down 4, 36 would be 32, and over 1 is going to be in the middle. Okay, down 4 from 32 would be 28, and over 1. Down 4 from 28 will give me to 24, and then over 1. It's going to be in the middle. Down 4 from 24 will take us to 20, and then over 1. Down 4, 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 and over 1. And that's Andrew's graph. Line out a little bit here. Ooh. If I can't straighten it out, that means I messed up. So I gotta figure out where I messed up. My plates are a little off all of a sudden. I think it's down here at the bottom somewhere. So let's see, down 4, over 1, down 4, over 1, down 4, down 4, over 1. Okay, hopefully that's better. There we go. Much better. Okay. And here's my point of intersection, which is the point over 4 up 20. Okay, so as far as the questions go, first question is, what is the coordinates of the point of intersection? And that was 4 and 20, which the 4 is the x, that would represent 4 minutes, or 4 seconds, excuse me. And the 20 would be the distance, or the feet, 20 feet. So that's the time that they meet, and I also threw in the distance there. Okay, next question is writing the equations, and then verifying that they really work for that point, which will tell me that I wrote the equations correctly or not. So Jeremiah's equation, he started at the bottom of the graph, so he has the positive slope, and his rate was 5, so his equation is going to be y equals 5x. No plus anything because he started at the bottom of the graph, so it'd be plus 0. Andrew's equation, Andrew's rate was 4, but since he started at the top of the graph, he's going down, so it's going to be negative 4x. And he started further away. He started at 36, so plus 36. Okay, so now I want to verify that those equations really work for the point that I found. So I'm going to plug in my point, 4 for x and 20 for y. So with Jeremiah's equation, it would just be 5 times 4. Does that really equal 20? And yes, it does. So Jeremiah's equation checks out. So now I want to see if Andrew's equation checks out. So we're looking at negative 4 times 4 plus 20. Or no, plus 36, excuse me. And we want to see, does that actually equal 20? Well, this would be negative 16 right here, plus 36. I want to see if that equals 20. So negative 16 plus 36, and you can put that in your calculator. And yes, that really does equal 20. So that equation does check out. Okay, so the verifying helps you to see if your equations are written correctly. So that's a very important step. Okay, so that's looking at two graphing stories, seeing where two people end up meeting up. One's going to have a positive slope, the other one's going to have a negative slope. The slope has to do with whatever the constant rate is. So whether they're walking, whether they're running, whatever their constant rate is.